We'll go to the new workspace button to open a new workspace. Get asked if we want to save. I'm just going to say no. Now we're back in a completely blank workspace. We support like a really pretty wide variety of file types for import here. We're not going to get to test all of them today. And most of them are supported just by dragging and dropping into the workspace, just like that GeoH5. Yeah, speaking of importing object types, Alexi, did you manage to get GA reinstalled?
Yeah, it worked.
Okay,
I just reinstalled and now I had like some issues following, but I
you met you
understand the
met.
platform a bit, but there's a
Okay,
video anyway, so
okay, yeah, I'll convert
yeah.
all
So
the
it
notes and
works.
okay, perfect. That's good to hear. Something
Yeah.
must have gotten a bit of a hiccup there with the install. Um,
Uh-huh.
yeah, that DXF message that's what that was pointing to, as far as I can tell.
Yeah.
Okay. We're kind of starting fresh now from here, at least. We are going to be using several of those things that we looked at in the earlier just for visualization, but you should be able to follow along with me, follow where my mouse is going. And then afterwards, if you want to come back, like we'll be sharing the video, and I'll try to put all these speaking notes into an actual set of exercises or instructions to follow instead of just kind of talking at everyone. Right. Imports. So let's take a look at that exercise 9 folder. And it should look something like this, with 2 CSVs, a TIFF, and a topography DXF. So let's first bring in the DXF and the TIFF. You can actually multi-select these and bring them both in. And you should see something like that right after dragging and dropping them. So just like I was touching on earlier, that PNG comes in as just a plain or flat image, but we can drape it on top of that topography surface. So maybe the first thing to do here is try to set up our container organization so that it's not quite as messy. We're not going to need this 2D grid. The 2D grid, any image you bring in will come in as any TIFF, pardon me, that you bring in will come in as a 2D grid as well. In this case, we're not going to use it, so we can right click on that and delete it. Just make sure that it's the 2D grid and not the geo image. So we still want to see this Flin Flon Geology geo image. If you've deleted it, that's okay. You can re-import it. Any of these objects that you import lose their connection to the source file that you imported it from. They're all self-contained inside your GeoH5 workspace. You can edit them, re-export them. This is not like GIS where your shape files you're actually working directly on the file. It's a completely self-contained workspace container for all your files. So that being said, like also if you bring in a CSV, make edits to some of the data, remember that that original CSV is not changing. You need to re-export it and bring it in again if you'd like to edit it and then send it elsewhere. Something to keep in mind. Right. Yeah, let's organize this. Okay, so topography. We have that topography surface. Comes in as topography meshes just because that's the way DXF files are structured. I'm going to take meshes off the end. I'm going to put these two in the same container under raster imports and just rename this one base map. And we'll take AutoCAD imports and we can delete this container group. So if you followed that precisely, you'll have a base map container group with Flin Flon geology and topography. And then from there, we'll do the same thing we did previously. Pick topography and paint it by that Flin Flon geology image. Mine still looks yellow because I've got the whole thing selected. And it looks big because I've got that geo image turned on, so I can turn that off. Now I've got a base map to start with. And I'm just going to set my viewing angle here to look straight down. Okay. Just a couple quick things to start out with your with a base map and an actual topography surface. The next things we're going to want to bring in are those CSVs. Those can be imported by dragging and dropping as well. So we can take our field measurements and outcrop geochem and drag those in. If you've already looked at these, good on you for being keen and checking out what the CSV structure actually looks like. But we'll take a look at them inside GA in just a moment after we've imported them. These CSVs can be imported as points, curves, targets, or ellipsoids. Targets being drill targets. We'll take a look at those later. Curves do need some kind of a piece of reference data to indicate which line is which, line 1, line 2, line 3. And ellipsoids are something I wouldn't use. That's a geophysics thing. The required fields for points are X, Y, and Z coordinates. At bare minimum, you need those. We don't need to double them up and keep them selected under all fields, but you can scroll down through these other columns and see what else is in here. There's a second X, Y, and Z property in here for some reason. I'm deselecting both of those. And then you get a preview of what this CSV looks like in tabular format down here. So one thing that's jumping out at me right away is that our Z column is all full of zeros. So none of these points are actually corrected for elevation. They're just X and Y points. That's really common in historic CSV data. There's no elevation existing on them. We'll hit OK to import these ones. And then we'll immediately be prompted with the other one if you multi-selected it like me and dragged it in to bring in the field measurements. So here I'm going to do the same thing and deselect X, Y, and Z under all fields. And take a quick look at the data preview. So here we've got X, Y, Z, an azimuth and dip, and then a unit. So these are meant to be contact picks from an outcrop, some with structural measurements, some without. But yeah, the understanding here is that these should be either spatial location markers or orientation markers for our lithological contacts. And we'll hit OK to import those. So let's first take a look at the outcrop geochem. I'll turn off the field measurements by unselecting it from the object tree. And zoom out just a little bit. And what I want to inspect here with the outcrop geochem is that thing I pointed out with that Z field being set to 0. And sure enough, these plots are pointed about 300 meters below surface. So first thing to validate there is correct the elevation. We can do that really quickly by right-clicking on the points and finding the drape on item in the menu. So right-click on the outcrop geochem and go drape on and drape them onto your topography. Should be the only option unless you've imported a couple copies of that topography surface. Click OK and see those points jump up to where they should be. Even the ones just outside the topography surface are brought up to approximately that elevation. The other thing we might want to check is, did these coordinates come in properly? And a quick way to do that, oh, I didn't need to do that one there, is by taking a look into the data table, picking maybe the first one or a handful of these, checking the X, Y, and Z coordinate. So that's the point I've got selected. I'll just turn the size of all these up a bit so they're easier to see. And go back to that first point. So that's the one right there. I can double check the XY coordinates with that tooltip marker, check that they're roughly the same. And then I can also open up that CSV in Excel, right? And find that point in the first row to double check that X and Y are the same and we haven't lost anything or changed anything on the import. A couple notes on importing things and spatial validation. So we don't do any on-the-fly coordinate reference system transforms. So if you are bringing in something like a geotiff or a shapefile that has a CRS associated with it, there will be no on-the-fly transform because we don't set a CRS to associate at a workspace level. Each object you have can have a specified CRS, and we can do those transforms, but you need to do it manually when you bring the objects in. So you can find those options under the right-click menu to specify coordinate system. And in this case, I know that this area is in UTM zone 14 North, so I could specify that there. And then if I wanted to transform it, I could do something like this and transform it into a lat long or back and forth. If I bring something in lat longs, do the inverse. But the important part to remember is I need to do that manually. It does not happen on the fly. Okay. So that's enough about spatial validation. Let's also take a look at the data validation that we're getting. I guess the thing I want to point out is that Geoscience Analyst is not a full-featured QA/QC lab analysis platform. So basically, when you're bringing your data in, we're kind of assuming that it's already been checked somewhere like Acquire, IOGAS, Geotic, one of the other logging or database management, drill hole database management systems. So we're not going to, we don't have any validation rules or anything that we set up in that context. However, we looked at sorting the data table, checking min and max values. Those are things we can do here just to make sure that those other processes have been done. So on that note, let's take a look at maybe our copper value in the outcrop geochem and try sorting that one. So sorting, oh no. Okay, we'll carry on, Hamza, but yeah, give us a shout when you get back up and running. So sorting the copper column, we'll see that there are a couple non-data value entries in here, and then the next value start at 0.3. So the assumption here is that 0.3 is actually at the detection limit or half a detection limit. I don't really want to get too much into the weeds talking about like lab precision and detection limits because that's something for another time, and it's not something we really handle here either. But essentially, we don't necessarily want to replace non-data with zeros or call below detection limits zeros because it's not technically correct and it can be misleading when we start interpolating or doing statistical analyses. Non-data values, like the top few rows in the copper column, should reflect somewhere we don't have the information. We didn't take a copper assay there. That's not the same as saying we know that it's zero. On the detection limit thing, the zero can be misinterpreted as that. So normally when we have a below detection reading limit on an assay, we might want to set a rule to call all those values at half a detection limit. But that's something you would normally take care of before bringing your data into Geoscience Analyst. You'd use Geoscience Analyst for spatial visual checks rather than doing your data validation and QA/QC, your lab data validation and QA/QC. Some things to keep in mind. However, there's a few ways that we can look at adjusting those values. We could replace all these non-datas with zeros, or vice versa. We can take a specific value and replace it with non-data. But I think what we might want to do is talk a little bit about capping some of these geochem values. This is something that's done pretty commonly to try to address outlier values, and prevent them from misleading us in our statistics or our interpolations after the fact. So let's, I'm going to turn that tooltip off. We'll sort copper again, descending this time, and look at the highest values. And then also while we're in here, let's just take a look at that CU-ppm and take a look at the histogram in the data colors panel. So we're seeing a pretty narrow, long tail with values leading up to that max at 1050. What we might want to do here, if we already know that we're setting our geochem cap, that's a value like 750 ppm, is edit these values that are above 750 ppm to match them to that cap. Before doing that though, let's make a copy of this. We should always keep the copy of the primary uncapped and unaltered data so we can refer back to it. Capping factors change. In reality, it's not as simple as just picking an arbitrary value and saying we're going to cap here. There's like a lot of advanced statistical analysis that goes into, yeah, go ahead.
I have a question. You say that we must copy this CSV, but just to get, when you start the formation, you told us that the data were like charged in the software. So
Sorry.
why do we need to have a copy if the data is in the software and we're not changing like the source CSV?
I hear you. Yeah, we're not going to copy the whole CSV. What we'll do instead is I'll take this property, CUPPM, Control C and Control V. Oh, not Control C, Control V. That copies the whole object. Take CUPPM and how was I going to do this? We need to do it with the script. Okay, we are going to make a duplicate of this data set that still lives on the same set of points. And we'll make that one the uncapped and leave it as is. And then we'll make, and then with the one that we edit, we'll make that one the capped copy of the CUPPM. So the way we can do that is by right-clicking on Outcrop Geochem, going down to Script at the bottom, fourth down from the bottom. That'll open up a window that looks like this. Output name is going to be the name of our new property. So we'll call this CUPPM uncapped. So this is the data as imported. All I want to do here is preserve a record of the data as it was imported before we edit it so that we can go back. Right, because where was I? In the event that our capping criteria change, we want to change capping factors, we can go back to this original one and edit it without going back and re-importing that CSV again. So the script here is really simple. It's just going to be the name CUPPM, and you can pick it from this suggestion box. We'll click OK. So now we have these two properties. They're in fact exactly the same until we start making some edits. So let's go back to our CUPPM, the one that we're going to edit and try capping on. And find where, there it is. Make sure that's still sorted descending. I need to resort, there we go. Resort the table if something has changed. So that should still be sorted descending. There's a button on the left-hand side of the data table to allow editing. You can click on that button and you'll see the data table turn white. And now I can click on one of these boxes and start typing something else in here. So if I want to do this manually, I can type this in and turn all those values above 750 to 750 and say, I've capped my data. Like I was saying, in reality, there's a lot more that goes into this than just kind of picking a value and trying to cut off a tail on a histogram, but that's a way that it can be done. Aside from that, let's take a look at, we're going to continue with this capping. The exercise here is mainly just to get us comfortable using filters from the data colors table and masking properties to kind of pick and select our elements based on some numeric criteria. So we also had lead and zinc in here. We'll take a look at those ones. We'll do the same scripts on lead and zinc to create some copies of them. So let's do a zinc uncapped. This one will be a copy of zinc. Oop. Double check when you're typing in script that this area is bolded. That means that it's been recognized that it is an existing property and you're using that property in your script. We'll leave that up there for a second. And this time we can just click apply which will run the script and leave the window open for us to run another one. Apply. Got those two properties. They should be exactly the same. And then we'll do this again for lead. Look all right. This time I'm going to click OK and it's going to close the window. Okay. Okay, let's grab our lead ppm. You can sort the data table there again to see the highest values. This one has an even more drastic outlier, this 2567. Another way we can do this is by applying a filter. So if I want to set my cap at something here, maybe something appropriate might be like 100. I'll filter minimum by 100 by typing 100 into that box. And that filters off everything except that one sample that's over 2000. Now, if I select that one, I can find only that one shown right here. So if I had more than just one of these, maybe I've got 25 and I don't want to type through the data table to cap all of them individually. I can go to Outcrop Geochem, create, and create a masking property. We'll use these a few more times in the next few hours. This is just a quick intro. We can create these masking properties. It's basically the idea here is that we want to break out certain elements or certain regions and maybe run an operation specifically on those ones and not others, or use some kind of a criteria to like a filter to break our point set apart and treat them differently. So in this case, we'll go creation methods by visible association to take only that one point that's still visible. The others are all invisible because we've set a minimum value filter on the outcrop geochem. So we'll call this output name lead outlier and click OK. So now if I reset that that value filter, show all the points again, but toggle on the masking property that just got created. One thing, first of all, once you've got it selected, it looks like a categorical data in your data colors panel. I've got false and true, and I've only got one true. So that should correspond with that one sample that we broke out. Now, if I tick that box on, just like previously when I had that filter applied, I can only see that one point. Right? Now, for just one point, pretty easy just to use that filter and go re-enter that value manually. But if you had 25, you might want to do it this way. And you'd want to check at pretty much every step of this stage, does the count match what I expect? So we could go and grab that outcrop geochem again. We'll go to script. This time we'll tick on masking and select that one lead outlier mask. And in this case, we're actually going to edit the existing lead ppm property. When I type it in exactly the same as it's shown in the object tree, now I've got this box is no longer grayed out. It's available for me to click in it. If I click in that, I'm editing that property. This can't be undone. That's why it's important to make that backup, copy that property using the script, because if you edit it with a script, you can't undo it. And it may not be the same. You may have been editing this kind of on an ongoing basis, and it might not be the same as that CSV anymore. You don't want to start back from the import if you've already made a lot of edits. And the script here Bear along with me. I'm going to type in it's a conditional. No, I don't need to do that. Sorry, I'm going to skip that one. What we're doing here is running the script through this masking filter. So since I've got this filter selected, or this mask selected, that only is marked true for that one point. Whatever we do here is only being performed on that one point and not on all 1,200 of them. And basically what we want to do here, I think we said, let's cap lead at 100 or maybe 200. We'll call it 200. In the script, I'm just going to type 200. And that says that values in this property should now equal 200, but only where that masking property is true. So we'll click OK. Now let's check if that worked by finding our lead ppm and sorting it. And if we sort it descending, we should see that 2567 value is now 200. So we capped that value at 200 by adjusting it with a script and a masking property. How are we feeling about that kind of stuff? The capping and the intention behind it, we don't need to go into the weeds on that. But what I wanted to kind of demonstrate here is how we can use those masking properties to just run a script and change something on a subset of the overall object. All right. Moving on. Now that we've applied some caps, checked, spatially validated our data, and checked the lower ranges of our data too, we can take a look at some interpolation. We'll do this first with a 2D grid, and we'll just to kind of build up the concept, and then we're going to move on to 3D grids. Probably tomorrow morning. So we'll turn off the topography. We've got our outcrop geochem. I've got mine painted by this masking property, so I can only see the one, but I probably want to view it by copper. So I'll turn those copper values back on. To run an interpolation, we need a 2D grid to populate, or a grid to populate in general. We'll use a 2D grid in this case. So to create that 2D grid, an empty grid, we can use utilities and the 2D grid designer. So find that guy from under the utilities menu. Okay, most of these grid designers have this nice object selection suggestion. So one way to do this is using this draw button to draw an outline. That gives us a rough outline of where we want our 2D grid to go, but I could also use that blue pick arrow to pick one of these points and then click the light bulb to suggest the extents based on the existing object. There we go. Well, so go ahead and do that. Pick outcrop geochem from the dropdown and pick the light bulb to suggest extents. But then let's just go to cell sizes and adjust those to, let's see, 25 by 25. Once you're satisfied with that, we'll go ahead and click create. And that grid gets added to the object tree. We can close the 2D grid designer. Now we've got what we need to run that interpolation. So the interpolation options for Pro and the academic will be found under utilities and transfer data. So look under that utilities menu, find transfer data. And here we need to pick a source object, a destination object, and a property or properties to transfer. So we'll grab, we can use that green, that blue screen pick arrow again, pick object. And then, the object should be the points and the destination should be the grid. For properties, we can pick multiple and run several interpolations at once. Let's take our copper, lead, and zinc values. And we've got two options here, nearest neighbor and inverse distance weighting. What we'll do is switch to inverse distance weighting. The idea here being that with an inverse distance weighting interpolation, for every and I'll turn on the grid. Okay, I hope that is not too hard to see with those colors. The idea here being that each of these cells, so this one is going to be populated using the points next to it, right? With inverse distance weighting, the influence which each point has is inversely related to its distance from the point. So the further away, the lower the weighting that point has on populating that grid cell. This is done for every cell, so it's a bit hard to picture on a one-to-one thing unless you're just looking at a single cell. But the alternative here is nearest neighbors. We were taking just 1, 3, 5 nearest points and using them all equally. Generally, the assumption we're making by using inverse distance weighting is that only the closest points have the heaviest impact on how we should expect values to change between observations. So we'll use inverse distance weighting rather than nearest neighbor, and we'll change the search radius here to 200 meters and turn on horizontal radius only. I'm using horizontal radius only on a 2D grid because recall that we draped our points to the topography surface, but the 2D grid itself only exists on a 2D plane. It doesn't mimic that topography surface. If we work a 3D component into this as well, then we're actually affecting how we're interpolating based on the elevation of the points, which isn't really correct since we're interpolating onto a 2D plane. Okay, I'll leave that window up there for everybody to copy my settings. Just for a second more. And if we're all good, then I'll go ahead and click OK and run that interpolation. It'll happen pretty quickly. Don't see any change right away because we have to still paint the grid by the data. So just like in that block model, we have grid and then cells. If I click over to cells on this 2D grid, I'll now see, sorted it. I'll now see those properties that we interpolated onto that grid. Then we can color that grid by clicking on them, sort them. So we'll color it by copper. I'm going to turn that grid option off in the visual parameters. And something key here, we kind of talked about these color scales before. This did carry over from the same way that copper was plotted on the points, but the color mapping, check that red line, is not really descriptive of what we're seeing here. It's almost always best to set your geochem data to a linear color scale. So we'll do that. Click linear mapping. And actually, you know what? Let's set this on the source data, actually. So clicking between CUPPM and CUPPM between the grid and the outcrop geochem points, we're seeing different histograms, but the same color ramp because they have the same data type. We don't need to reassign in this case. But what I want to look at here is look where that tail is coming off to try to assess where I want to place that top range on my color ramp. So I'll pick linear. My minimum, I can leave probably around, around the lower detection limit at 0.3. My maximum, I don't think I want to have at 750. I probably want to place more like 400. Because that will give me a bit more, it'll make variations in the lower range more visible and also make the higher values cluster together, which is a bit more visually descriptive. So in reality, we don't have bright purple areas because there's not a lot of copper everywhere. We should just be seeing those higher values isolated in nice little localized areas. Got one right here. So I guess maybe just visually, what do we think about how these values interpolated onto the grid? Like take a look and just do a comparison for yourself between areas, where we're working between clusters versus where we're working from a single point and away. and see how the different sample densities affect the overall interpolated grades on that grid. This is more of just a visual impression exercise now, but that's part of the process. Does it look right? Gut instincts, or did something go horribly wrong? Did I set something up in the wrong way? Is my sampling distance or my sample spacing not quite appropriate for the cell sizes? We'll see these kind of halo effects on inverse distance weighting pretty frequently. That's kind of a telltale sign. I'm looking at this blue, this lower grade point here, this green point here, and I'm seeing a drastic boundary. Does that seem accurate, or is it just that we've lost the influence from this point? Questions like that kind of help us look towards problem areas. How can we improve our understanding, or control how we're interpolating these values to establish continuity? The other question that I have is, where do we feel most confident about the grades that we're estimating in these cells? How would, this area here compare to an area like this as far as how confident you are in what the grid is telling us? We can answer that qualitatively for sure. The more data points, the more confident we can be. But what about when those data points all disagree with each other? And how can we quantify confidence in a way that gives us something actionable to say, produce a list of priorities in where to target our sampling? These are questions and themes we'll come back to in 3D after doing a little surface modeling exercise. Okay, that's another hour down. So do we feel like we need maybe another 5-minute break, or do we want to keep pressing on and start looking at something else? Or are there any questions or discussion things, thoughts that anyone's had that you want to take a look at?
We can take a 5-minute breaks. I don't know, like, if anyone wants one or not, but we can take one.
Okay, yeah, works for me.
Thanks.
My time says 3:34, so I'll start going again at about 3:40.